Fundamentally, nobody cares about software, nobody cares about material, nobody cares about the printers. Nobody cares about additive manufacturing. What we are demonstrating with BASF here is that if you bring together expert knowledge in material, if you bring together expert knowledge in algorithmic engineering and software design, I think you can build some very, very powerful tools that accelerate the adoption of additive manufacturing just simply by making it easy and making it fast to create functioning products.
So first of all, you don't need a very powerful CAD laptop. That is one difference. Onboarding somebody is really done within a matter of minutes. So within minutes now, you could generate lattices yourself. It contains all our lattice library, meaning that you have all these pre-selected, validated lattices for our GPU. So it really takes out all the guesswork for finding the right lattice type and how to generate it.
Hi everyone, today we have Markus, Business Development Director at Hyperganic, together with Marius, Product Manager for Services at BASF Forward AM. And we'd love to have a conversation about what we are going to launch at RAPID TCT. So Marius, could you tell us a bit more about Forward AM? What does it do as a subsidiary of BASF and what's its strategic purpose?
Yeah, first of all, thank you so much for having me. I think it's a great format. So Forward AM is really the 3D printing brand of BASF, and BASF is this is the largest chemical company in the world with more than 120,000 people operating worldwide, and BASF is mostly known probably for its chemicals, for its plastics and performance materials. Now, BASF 3D printing solutions, or BASF Forward AM, is a 3D printing material manufacturer. So what we do is we develop and we produce material for 3D printing. And this ranges from powders over resins over filaments. And on top of all these materials, we also provide engineering services. This means that we help our customers really from the mere idea to the final end application with design, simulation, with 3D printing, as well as post-processing.
All right, off to you, Markus. What does Hyperganic do?
Yeah, thank you, Linhan, for hosting this. So yeah, I mean, we do algorithmic engineering. So we help our partners and our customers to encapsulate their knowledge into code. And in this particular case, we made this code very accessible to a large audience. So in essence, what our aim is to be the catalyst of change for additive manufacturing, to really speed up and accelerate innovation in this space.
I think that sums up what Hyperganic does really well. Yeah, so like, why are we in this meeting, guys? What collaborations have we been working on? I know that Markus and Marius, you guys have been working together for almost the past year now, right, thereabouts. And could you tell me more about what you guys have been working on?
Yeah, for quite some time, I guess, right, Marius? Do you want to kick it off?
Yeah, I think we know each other quite well. We've spent hundreds of hours working together now for more than a year. Yeah, I would say the idea behind the Lattice Engine really is, and I think you already mentioned it, Markus, is to make lattice generation more accessible for everyone, and to fundamentally simplify lattice generation. Because if we look at where we started at, and this goes back 4 or 5 years, where we at BASF Forward AM first took a deep dive into lattices, and we developed material models to really understand our materials. We ran numerous tests to understand how our materials behave. We really wanted to understand how different lattice designs behave, what the influence is of different lattice types, of different cells, of different beams, etc., and really how to integrate these kinds of lattices into actual applications. Now, having gone through all the R&D, we understood that there's still pretty high knowledge barrier to creating functional lattices with the expected performances. So it needs all these engineering teams, it needs time, it needs money. And we really wanted to make this simpler, make it more accessible for everyone so that everyone can actually benefit of these lattices advantages. So this is really when we started to look for a partner who can help us with that. And I think this is exactly what we found within the partnership between BASF 4DM and Hyperganic. And this is actually, I think, how it was born.
Yeah, thank you. I think that summarizes it perfectly. I mean, the challenge that I think all see in the market is that in order to get to a validated product, especially with soft polymer lattices, you take months and months of R&D, right? And sometimes this is a dead end road, right? Because either you've burned so much cash and you've not validated any particular structure that you're willing to make the investment and to jump into AM, or you just continue and you never know when this journey ends. But what you would ideally like to see is you'd ideally like to have a one-shot success, right? You know exactly what you're after in most cases. You know what performance metrics you're after, whether this is Shore-A equivalence, whether this is rebound, whether this is tensile strength, whatever you're after, you know this in many cases before you venture into this journey. However, nobody has ever taken the time to encapsulate all of this knowledge in a very accessible way, yeah, or in a structured way. We basically brought together the best out of two worlds, right? On the one side, we have BASF with a vast knowledge of materials and different lattice structures and the testing of these lattice structures. And on the other side, we have, on the Hyperganic side, we have a very powerful geometry kernel that we can use to leverage this know-how and to encapsulate this knowledge and make it accessible to a very large audience in order to achieve this one-shot success with soft polymer lattices that previously took months and months of R&D and trial and error.
So it sounds to me like engineering knowledge can be encapsulated by software, but why Hyperganic? And how was life like at BASF 4AM previously before you found us? And what made you go, okay, this is the dream collaboration?
So the way we worked before we met, or before we decided to partner up together with Hyperganic was we provided the lattice engineering or lattice generation as a service. And this is something that we have within our portfolio. And what we would typically do is we would engage together with the customer to screen the requirements. And then based on the Lattice Library that we have built up in the back over the past years and years, we would identify the right lattices. And we would use, sophisticated softwares out there to generate the lattices into the actual application. So we would do it ourselves, and this would be mostly based on the experience that we have gathered in the past. But it would require, let's say, a few engineers that had very specialized expertise in that, in understanding how you generate a lattice, how you can transfer all the characteristics to the actual application so that it performs in the way it's supposed to. Now, with having found Hyperganic, we allow users and customers to really do this kind of lattice generation themselves. So we basically open up now the possibilities or the user group to everyone, because what we have done is found a very simple and nice way on how to transfer all this knowledge into specific codes that we integrate into the software, so that people now can simply generate their own lattices themselves in a matter of minutes, rather than in hours or weeks or months.
So Marius, you say that the big challenge is that you needed to have a team of engineers essentially with quite a bit of very expensive CAD tools that would take weeks or months in order to produce a part. So how would a user do this now? Can you explain this to us? Like, what is the workflow that a user now takes in order to get a performance lattice out of their file?
Mm-hmm. The main difference really is that it's very simple. And probably you can already tell by the time it takes to onboard somebody. This is really something where you can see how quickly you can fully understand the software, because Ultrasim 3D Lattice, the Ultrasim 3D Lattice Engine, is an on-premise solution that you download and you install it on your computer, and it runs on any laptop. So first of all, you don't need a very powerful CAD laptop. That is one difference. Onboarding somebody is really done within a matter of minutes. So within minutes now, you could generate lattices yourself, and it contains all our lattice library, meaning that you have all these pre-selected, validated lattices for our TPU. So it really takes out all the guesswork for finding the right lattice type and how to generate it. And there are basically two different ways to do this. Once you open the software, you can upload your solid STL. And then the first way would be you can choose basically a code on a physical lattice testpad. So this is the first way. The lattice testpad is made out of our TPU. It is engineered for certain applications. We have those for protection, we have those for seating, and we also have those for footwear. It's ranges in one side in different cell sizes, and in the other side in different beam thicknesses. And it goes really from A1 to A4, from A1 to D1 and to D4. So 16 different elements, and that really changes the show hardness and the mechanical performance. So what you can do now as a customer, instead of figuring out what would be the best lattice type for a footwear application, you simply take this lattice testpad where we already use the right lattice types for footwear applications. Now you compare your footwear application, the traditional part, with the testpad that you want to replace it with. You basically press on all these different elements, and once you figure out the right lattice type that you want to have, you use a code. It can be A1, it could be C2, something like this. And now within the software, you only have to basically choose now the code, and then it's being generated directly into your footwear application.
That's very cool. That's very cool. So this is the journey of direct tactile feedback, basically, right? So it gives you haptic feedback that you can translate into your digital product, and then, of course, after printing, into your physical product. How do I go about it if I don't have the test pad, but I have a very clear understanding of the physical parameters I want to go for, that I want to see in my lattice? How do I go about that?
That would be basically the second way, because we have a lot of customers out there that have already a very good understanding of what kind of mechanical performance the part is supposed to have in the end. They would know, let's say, the exact show hardness they want to have in a specific area. They would know, let's say, the stiffness or the density of the parts. So what you could do then is, the Ultrasim 3D Lattice Engine is always connected to our Lattice Library. So you can open up the library, and within the library, you will find all these different lattice types that are again coded from A1 to A4 for protection, footwear, and seating. And each of those will have the specific lattice data in the background. So here you can really do a deep dive into the mechanical characteristics of these lattices. It goes from, what is the density, what is the show hardness, what is the stiffness, what is the compression stiffness at certain different pressures. You could also, so it also includes, for instance, the stress strain curve, so you can really see the curves behind there. So then you can really match as a customer your requirements with the stress strain curves that are indicated in the Lattice library. And once you found there the perfect match, you again choose a code, open up the software again, just simply insert the code in there, and then you can generate your lattice.
That's very cool. That's very cool. And I mean, there's some applications where I don't just want to have one lattice, right? But I want to have a transition. Maybe I want to have softer areas. I want to have harder areas. I think we worked out a really cool workflow around that. Maybe Marius, I think you're the best to want to explain that. Do you want to go into a bit of detail there?
Yeah, that's a question that a lot of customers ask, because typically when they have an application, they really want to have or they want to really make use of the full potential of lattices. And the nice thing is that you can manipulate the lattice structures in a way that has a certain show hardness in one area, but another show hardness in another area. So we can use these kinds of multi-zone lattices also within the software. And this is typically done by creating some kind of black and white image, or a heat map that you can put on top of your part, let's say an insole or a midsole or a seat. And then based on this heat map, you can select within the software the different codes that you want to have. You can make it softer in one area, and you can make it hard in another area. And this is then being generated by the software itself.
Yeah, and I think that is a very, very powerful feature of the tool at the end of the day, because the part you create actually has different physical properties in different areas. And I think this is something that we heard a lot from the market, that this was a challenge, because the question that arises out of this now again, how long does it take me to generate such a part, right? Like it all sounds like rocket science, but how long does it take me? How long does the user journey take from the first time I open the app to the point I actually have a prod with a performance lattice?
Yeah, that's I mean, the onboarding is done within a matter of minutes, and we've seen it, I think, over the past months now. We first started to launch the Lattice Engine as a beta version on Formnext last year in November, and ever since gathered all the customer feedback, and we've got amazing response. It really seems to solve the problem and remove barriers for so many Lattice users that they used to have. And it's really great to see now customers or users that have been beginners within 3D printing, or let alone beginners within the Lattice world, to come up with a functional Lattice part within just a matter of minutes. And that's really great to see, and guide them on the journey on this. So I think yeah, that's really it takes out a lot of guesswork, and it really accelerates the complete product development.
And I can vouch for myself. I'm a newbie to Lattice, and I spent maybe 2 minutes designing a seat, right? And I uploaded the heat map that I can find, and it actually created a multi-zone modulation of the beam thickness. And yeah, and it's like, it's not linear multi-zone, it's actually like a gradient transition. So that part is really cool. Yeah.
Yeah, absolutely. And that, I think, is in line with the feedback that we have gotten so far.
Cool. I've encountered, however, some users that say, this is all great, I can get that out, but I want to have my own lattice. I want to have my signature lattice, a lattice that nobody else has. How can I go about that? Like, explain what we worked out.
So the Ultrasim 3 Lattice Engine is kept very simple. It has basically two different modes. The first mode is the BASF lattices. So this is, again, really all the lattices where we have gather the data using numerous tests and a simulation that we have basically the experience on within the BASF for decades now and come up with this lattice library. So all of these BASF lattices, they're validated, they're pre-engineered for certain applications, and they provide all the mechanical performance in the background. So you can trust that these actually work. Now, the second mode is the lattice playground. And the lattice playground, as a name already says, you can now choose from all these, let's say, from the complete lattice universe that is out there. So all different kinds of lattice types. And you can play around with certain parameters. You can play around with the beam size, with the cell size, with the beam thickness, and aspect ratios, and really try out what's possible actually, and this way create your own unique lattice. Now, in the end, this is more of a playground, and you still have to test whether this is then again printable, whether it's depowderable, whether it makes sense for the application. So there is all the guesswork in there, but this way you can create your own unique lattice.
Cool.
And I think in addition to that, so the lattice that we have in there right now, also in the BASF lattices, this is not the end. We will continue to extend the overall lattice offering with all different lattice types that are suitable for certain applications. So there will be more in future.
So this question goes out to the both of you. What potential applications can we actually build out of this lattice engine? Where is this going, right? Because we understand that this is just only the beginning.
Yeah, Marius, I'll leave the start to you.
So over the past years, we have seen a lot of potential for lattices within all different kinds of areas, and really focused on protection or protective gear, focused on footwear applications as well as seating applications. And this is why we have identified lattices that work especially for meeting the requirements out of those applications, so that they would have the right energy absorption, the right rebound, the right show hardnesses in these areas. So these are the kind of applications that where we see the most potential, and where we have now developed and produced these lattice test pads that you can see here, and come up with the lattice library in the back for that.
Yeah, and I think there are a myriad of applications. I mean, you covered the most important ones. I think a strong or big potential that TPU, that soft polymers have in additive manufacturing is mass customization applications. And we have from the side of Hyperganic supported several customers on their journey into mass customization, because in mass customization, as the name says, you need to tailor a product to many different individuals, right? And how do you best go about this? And like this cannot be a CAD workflow, especially not at the level of complexity that we're working at here. So what we've helped several customers with in the past is to build a very streamlined solution that takes in this know-how of latticing, the lattice performance in certain areas of the part, and translates this into scalable solutions that can run on a server, that can run on local hardware, that produce one part after the other without ideally human interaction, but fully automatically. So if we think about insoles, if we think about protective gear, that is really an area where algorithmic engineering and Hyperganic can play out its strength. So yeah, this is I think the BASF 3D Ultrasim Lattice Engine, I think is the exact perfect start point on this journey to validate the initial lattice, to validate the initial product. And then in order to take this into scalability, I think then BASF and Hyperganic are very committed to help the customers out there.
That's excellent. Okay, so after hearing all this today, where can someone who's interested in trying out the Ultrasim 3D Lattice Engine get their hands on it?
yeah, for that, feel free to visit our website. That's BASF and or of course Hyperganic as well. There you will find additional information. You will find videos. You will find use cases. You will find additional details to the Ultrasim 3 Lattice Engine. And if you want to test it for free, then simply fill out the contact form on the website, and we'll come back to you. And with this, then you can try out the software and familiarize yourself with it. That would be the way to go.
Cool. Yeah, we're very excited. I mean, as you mentioned, Marius, the feedback we have from the existing users is incredibly promising. The use cases that bubble up are quite surprising and interesting. There's a lot more to come. Way to go.
What message would you like to leave the audience with about the importance of collaboration within the AM space?
Yeah, that's a good one. So I think fundamentally, nobody cares about software, nobody cares about material, nobody cares about the printers. Nobody cares about additive manufacturing. Let's face it, it's an inconvenient truth, but it's unfortunately true. But what people care about is how quickly they can get to a functioning product. And AM is just a tool in their belt. And I think what we are demonstrating with BASF here is that if you bring together expert knowledge in these fields, if you bring together expert knowledge in material, if you bring together expert knowledge in algorithmic engineering and software design, I think you can build some very, very powerful tools that accelerate the adoption of additive manufacturing just simply by making it easy and making it fast to create functioning products. So that would be my take.
I fully agree. I think 3D printing is, let's say, the 3D printing market is it's very exciting. It's innovative, and it comes up with a lot of solutions that maybe used to be unthinkable. But we also know that all these solutions cannot be provided alone. And I think we are sitting in the same boat. So we at 4DM, we really believe that the only way forward is together and really continue to drive that.
Those are really powerful messages that were shared earlier. All right, Markus, Marius, I thoroughly enjoyed listening to you guys, thoroughly enjoyed participating in this conversation. Where can people find you? What are your contact details? If they want to get in touch.
Ideally via LinkedIn. It's the fastest journey. just reach out to business@hyperganic.com. Send us a message, and we're looking forward to connect.
Same for us. So you can reach us via LinkedIn through our official, let's say, LinkedIn account. You can also just shoot me a message, Marius Haefele, via LinkedIn, or just shoot me an email. I'm there to help, so I'm very much looking forward to your feedback. And yeah.
All right. Thanks, guys. See you next time.
Great. Thanks, Linhan, for hosting us.
Thank you so much for having us.
Bye.